everyone. Welcome to the second episode of our podcast about all things Docker, around all things AI. And this is my pleasure to welcome in our virtual studio the guest, who is Jacob Howard today. Jacob is a principal engineer at Docker. He's the tech lead for the AI runtime team and an established author on the Docker blog. And in general, a brilliant engineer. Hello, Jacob. How are you doing?
I'm good, Oleg. Thanks for having me on the podcast.
Well, it's not a podcast officially. It's a live stream. It's a technical live stream. We're gonna look at some demos. We're gonna talk about Docker model runner, specifically how it's implemented, how it works, and what to expect when running that on Docker CE. So in Linux environments, the open source component for Docker model runner, and we're gonna try to maybe look a little bit at whether this is transferable to Kubernetes, how to deal with that, and all things around running large language models locally. So sort of small large language models with open source Docker components. So to set the stage, recently you wrote a blog post about Docker Model Runner, our aspirations, why we built it, how we built it, provided a little glimpse into the diagram of how it's all connected, that it's not just a runtime that takes weights and does a lot of multiplications, but there is a lot of glue infrastructure around it that makes it actually the Docker experience, right? There is a scheduler and there's an installer, and the models come in as OCR artifacts, and then you need to balance things out and provide this unified experience, how we expect all things Docker work. And at that time yet, it wasn't available in Docker CE, so it wasn't yet an open source component, but that was a feature in Docker Desktop, right? So now that was a few months ago, and now we are at the stage where it is available in Docker CE, and we can take a look at that. So this is my first questions, right? How do I get Docker Model Runner working in Docker CE, and how do I get around using it?
Yeah, sure. So a lot to unpack there, but yeah, we can start with the Docker CE side of things. So for anyone who doesn't know, Docker CE is what we call Docker Community Edition. I think that's what it stands for. But we also kind of colloquially refer to it as Docker Engine. So that's kind of the open source component of Docker that is part of Docker Desktop, but it's sort of a subset of Docker Desktop. So in Docker Desktop, we take that Linux Docker engine and we kind of package it up with all sorts of OS integration magic and make that available. And in that case, we have Docker Model Runner built into that. But for Docker CE, which is what you might install on like a cloud-based Linux server or a Raspberry Pi or something like that, it's actually a separate package that you can install. So actually, let me screen share real quick. So yeah, if we go, if you search for like Docker engine install, we actually have like separate repos that we maintain, and these are kind of like the de facto official Docker CE or Docker engine repos. And inside these repos, we have a package called Docker Model Plugin. And this is very similar to like Docker Compose plugin or Docker BuildX plugin. It's basically a CLI plugin that gets installed on your system that Docker will know about as a subcommand. So actually, I can kind of show you real quick. So this is actually with Docker Desktop, not with Docker CE. But like, imagine if you had a Raspberry Pi. So once you did something like sudo apt install Docker model plugin, which you can just install right alongside like Docker Engine and Docker Compose plugin and all these other things. But once you have that, you'll have a new Docker subcommand called Docker model. And inside there, for Docker Engine, you're going to have these two commands, Docker install runner and Docker uninstall runner. And what these will actually do is provision a Docker model runner instance as a container inside of your Docker CE engine. So it's a little bit, it's a little less opaque in the sense that like you can actually see the container running. Like if you do a Docker PS, actually I can kind of show you with kind of a hidden one here, because I think I have Docker Cloud, or sorry, Docker Offload turned on, and I can kind of show you what you would see though if you had this container in place. So you would see something like this. Again, it depends on your hardware. If you don't have a CUDA GPU, you would see like latest CPU here. But you're going to get this Docker model runner container, and that'll be exposed on localhost port 12434. And you're also going to have a Docker volume associated with that where the models are going to be stored. But in order to get that installed, what you have to do is run Docker model install runner. And there's a couple of flags available to you. So you can disable analytics for it if you want, and you can also disable GPU support. By default, it's set to kind of like auto detect do you have a GPU or not, and you can control the port that it's installed on. And then if you want to get rid of it, you can do Docker model uninstall runner. And there's a couple of options there. So one is you can remove the underlying images that support the Docker model runner in Docker CE. And the other, which is not on by default as well, is to remove the models associated with it. So when you have, I don't know if I can see the volume here. I think I need to do something like, sorry, I'm kind of just flying by the seat of my pants
No,
on this one, but
it's all fine. Mike, like
yeah.
what I would be interested in. So when you run Docker desktop, right, it's all part of the Docker model runner is a process running in the host. And why did we choose to implement it with containers and volumes in CE? Because it breaks it, like the abstraction starts leaking way more.
Yeah, I mean, well, I don't know if I'll call it leaky, but essentially what we wanted to do is always provide the best performance. So in terms of inference, that means GPU access. And with Docker Desktop, as I said, it's not just Docker Engine. You have this whole VM infrastructure around it. And getting GPU pass-through to go through a VM and work efficiently inside the VM is, I would say, impossible to do in a way that is both stable and efficient. And so we decided that we were going to run the inference processes on the host, but then still kind of use all the networking magic that we install on Docker Desktop to make access to those GPUs from containers look as if it were running inside the container. But still get that performance on the host. In the Docker CE case, it's a little different because we're running only on Linux, so there is no virtualization barrier between the host system and the container. So all of the host hardware, in particular the GPUs, is available to containers. And beyond that, if you have something like the NVIDIA Container Toolkit and all the CEI infrastructure that supports, then you get all of the device mounting and user space libraries that you need like automatically mounted into the container with a very simple configuration. You just basically run GPUs all, and runtime is NVIDIA. I mean, it depends on the exact GPUs that you're using, of course, but the idea is basically there's less of a barrier there. And so in that case, like we like containers as our distribution mechanism. And actually, even in Docker Desktop, when we're shipping out Docker Model Runner, most of the components to it, in fact, I think all of the components to it are still shipped as containers. Like when we ship out updates to the CLI plugins, those go out as containers. And so it made sense in Docker CE to use containers as the shipping mechanism for the model runner, right, even though it's a different mechanism. Yeah.
Okay, I understand. Containers are very good for production environments, which for Docker model runner means very often your Docker CE installation or your Docker desktop. No, I understand. Okay. So I can install this on my if I have a machine and it has Docker running, I can install it and run my models, right? And then even if I don't have the GPU, I can run like a small large language model thing. Can I do that in CI? Would that work?
Yeah, you can. We don't have a dedicated GitHub action to it for now, but like you can install Docker CE. Like I mean, some CI environments is already installed by default, but you can also install it by a script. Which, see, there's kind of a demo available somewhere, but I was going to show you. Yeah, here. So you can kind of see. Basically, this is just like, as I said, kind of using the Docker model plugin installation as described in these install docs here. and in this case, pulling a model down, and then in this case, it's actually interfacing directly with the API endpoint using curl. But actually, once you did this Docker model plugin install, you could actually run like Docker model run to do this here as well. But as you can see, it's an OpenAI compliant API. So if you had other tooling like in your CI, like maybe you had some sort of Spring AI application that you wanted to test against Docker model runner, and you had developed it locally on your MacBook Pro, and you wanted to just like have kind of a smoke test in your CI system to verify that that was going to be working properly as expected, then you could set something up like this. I don't have an exact timeline, but we basically want to have a GitHub action to kind of automate all of this. But for now, it's kind of, yeah, like you said, you can just use the Docker CE docs like you would for any other platform, and then install the plugin.
That would be an amazing external contribution. If somebody who is like really proficient in GitHub Actions, Docker model runner, I know it's an open source component, so maybe this could be your contribution to the cost. So this is GitHub Action, right? So the worker is fairly small. It's what, like 16 gigs of RAM and like one CPU. Can you show the action run? I want to see if it, because like the curl should print you some performance stats at the end, right?
Yeah, exactly.
So that was this like 0.6 billion parameter model, 600 million, and that was a little, what was it, a quen?
I believe this one was sorry, hold on, this screen sharing thing, they always just get exactly where I don't want them to be. Yeah, let me go back to that.
I think it.
Yeah, there we go. There was a Qwen3 GGF file with 0.6 billion parameters. And
okay, so a very small one, and we asked it to run 500 words about Rome, which is
looks like it got that.
I don't know where. Yes, and then there are some stats. There should be some stats about performance of this.
Yep.
So it gives you.
Those are dumped out right here.
Do you see token per seconds prediction? The number is 44.
Yep.
No.
Yeah, no, it is. Yeah, 44 per second.
Okay. So it's not that bad.
No, I mean it's
that. Like you can probably.
There's a lot of these small models that you can actually pretty viably run in, like, again, I've run them on my Raspberry Pi before. Like, not, again, I'm not talking 30 billion parameter models, but like you can find modern CPUs that are more than capable of running some of these LLMs for sure.
That is awesome.
Yeah, I mean, certainly for a smoke test, it's fine, right? Like if you just want to make sure that like I haven't broken any like API linkage or something like that, having just some level of testing in place to make sure you get a response from the model runner is a useful abstraction to have.
Right, but if we talk about performance, right, to run this, we do need the GPU. Like that's like a sensible option.
Yes,
to make it faster.
And
can we like how would you go around like assessing your hardware requirements for a particular model, or like if I give you a model or a family of models, right? Like say we want to run the same like Qwen3, right? And it comes in different sizes and it comes at different quantizations, and you have a particular machine, like for example, Docker offload, right? What's your thought process about what size model can you fit there? Is it trial and error or?
Yeah, what I would do? No, I definitely not trial and error. So there are some aspects that are trial and error, right? Because with the model, you have a couple of different parameters you control, right? Like, or what they call hyperparameters, right? So one of which is just the number of parameters in the model. So in this case, like I'm looking at the Qwen3 model here on Docker Hub, and if all of our models have these model cards associated with them, where you can kind of get an overview of what the model does, and what it's good for, how many parameters it has, how many different variants it has, right? So like one of the main things that controls a model's behavior and intelligence is the number of parameters, right? More parameters, generally speaking, better model. Obviously, there's advancements in models that change the relative value of different parameter counts. and that's changing very rapidly. But generally speaking, more parameters is better, right? Um, and so if you go to Docker Hub's model card pages for these different models, you can see an estimation of what the VRAM being video RAM usage would be for a model if it's using your GPU. So like this totally unquantized Qwen 3 model with 30 billion tokens would be something like 60 gigs of VRAM. So you're going to need a big GPU or potentially multiple GPUs linked together to be able to load that into memory. I mean, some things are hundreds of gigabytes. But you can find stuff here, and we generally tag, like when we upload a model to Docker Hub, whenever we specify the latest tag, we generally pick a balance of a parameter count that's going to be good for most people. So even if you have like, let's say a MacBook Pro with just 16 gigs of RAM, which you can still do a lot with, we're going to pick a model that's probably going to work for most people. If you have a NVIDIA L40S GPU or something with, I think that's like 40 or 48 gigs of RAM, you might want to go ahead and customize that and pick a different tag, like a different, either a larger parameter count or a different quantization, right? And so that's the other aspect of this, right? Is like beyond the parameter count, you have the quantization, right? So you have like 16-bit floating points, or you have integer quantizations, and those also affect kind of the fidelity and execution of the model. And it's something you kind of have to experiment with, right? Like what's right for your particular use case. But the point is, right, like if you have a quantized versus non-quantized model, the quantized models, like in this case, we have identical models, same number of parameters, but one's an integer quantization. Actually, I think we have all three of them here. One's an integer quantization that uses significantly less VRAM, and one is the full like 16-bit floating point values that takes up more VRAM. So you can kind of get an estimate that way. And then the third major parameter that's going to affect it is the context size that you pick. So we pick a default context length of 4,096 tokens in Docker Model Runner when you run a model. But there are ways you can customize that when you run a model, like through Compose, for example. And I can show you that a bit later if you want. But again, for tool usage, building agents, that kind of thing, you want to have a larger context length usually. And in that case, that's also going to affect your VRAM usage. And it's not a linear scaling necessarily. Like if you double the context length, you might not be doubling the VRAM. It's kind of a more complex equation in terms of computing how much VRAM is going to be. But again, if you just want to kind of figure the out of the box VRAM, whether your hardware is going to make it or not, you can kind of go look up the specs for your GPU. Or if you're on a Mac, for example, like if you're on an Apple Silicon Mac, your GPU memory and your like host memory are shared. There's all like a unified memory fabric. So in that case, if you said I have a 16 gigabyte VRAM MacBook Pro, then I can probably fit a VRAM a model that takes up 5.5 gigs of VRAM inside of that. But yeah, beyond that, you have to start tweaking and experimenting, and especially with context length, you really have to start experimenting. So you might specify a context length of like 30,000 tokens and find out, yeah, okay, I don't have the memory to load that, and maybe you like kind of do a binary search down. Okay, can I load 15,000 tokens or 10,000 tokens, or so on.
Okay, yeah, I understand. So that's like the lengths of the conversation that we want to have at once. So if I'm having like the context lengths, right? So if I'm having an application that sends individual prompts to my AI backend and gets the results, for example, I send product information and I get like marketing emails for that product, which is like this big. My context size doesn't grow infinitely because it's not an ongoing conversation, so I can like have it shorter. So is it use case specific, I assume?
Yeah.
I have another question. So there are like the whole zoo of models that we have there and at the in the AI namespace, and we run all them and we use the Llama CPP as the backend, right?
That's right. Yeah.
Do we so naturally we don't like, do we take the Llama CPP from upstream? Do we sort of tweak it ourselves? And like, is it a separate download, a separate component for us, right? Do we update it faster, like more frequently than Docker Desktop, or is it like a monthly cadence? When a model comes out, like say Meta comes out with a new architecture for a model, like how often, like how quickly can we support that, and what's required for this?
I would say it's highly dependent on the model vendor. So yeah, there's kind of two aspects of a new model's release, right? There's the actual like tensor weight files that we need, and those are usually like released on launch day, right? And then we also need support for the model family in Llama CPP, so that has to be kind of merged in upstream. Generally speaking, most vendors will like kind of start opening up the PRs on Llama CPP like a couple days in advance or even a couple weeks in advance. And in a lot of cases, like the model architecture doesn't actually change, right? It's just a refinement of the training for the model. So sometimes we don't actually even need to update as long as it's an existing model family that we're pulling down a new model for. Um, but yeah, generally speaking, we just pretty much take. So we do have a separate pipeline for building our Llama C++ binaries that we ship out, but it's a very thin. Like it's basically, in fact, the only reason it's kind of internal is just because we have like build automation steps that we don't have available to public repos in Docker on GitHub. But generally speaking, we pretty much just like have a Git subtree that we pull in and then build that and then ship out the artifacts from there. There's not much we've added. The few things we have added, we've generally upstreamed.
Mhm.
But actually, yeah, fortunately, it's in the particular case of Llama CPP. Sorry, I'm never sure if it's Llama CPP or Llama C++. I call it Llama CPP because it's faster to say, but I think it is Llama C++. So forgive me if I'm misnaming it. But yeah, generally speaking, we can update and ship out a new release within a couple days. And in Docker Desktop, those are brought down separately as a background update, so you don't have to do a full Docker Desktop update. In the case
Mhm.
of Docker CE, we don't auto update, but there's a very simple solution to that, which is we will ship out a new model runner image. And so you can just do Docker model uninstall runner, Docker model install runner, or again, it's auto installed if you run a Docker model command. And that will get you a new version. Actually, sorry, you need to do Docker model uninstall runner dash dash images. That will delete the old image, but without deleting your models. And then you can do install runner to get an updated version. But in Docker CE, where it's more of like a deployment oriented Docker engine, we didn't
Yeah.
want to like take the risk of like updating Llama CPP and suddenly breaking your install.
No, no, makes sense. Makes sense. We have a sort of a question from Max, which is maybe we can dive into having multiple backends if that is on the horizon. So in the article, you said that we wanted to have an extensible architecture where maybe we can have multiple actual like runtime backends for running models. Um, like, is it hard to do? Is it? Are we working on it? Can we say anything about that, or
I don't
could
know
this
if
be a contribution as well?
Yeah, I mean, so we're always open to contributions for sure. And actually I wanted to highlight it because it might be a little hard to find, but like we have three repos underneath the Docker namespace on GitHub. There are public repos, which are model CLI, model runner, and model distribution. And these are all open source and Apache licensed. And these are what go straight into Docker Desktop. Like we literally build the artifacts from these repos, and then they're just dependencies that go right into Docker Desktop and these other images and Docker CE. Um, so yeah, totally open to contributions. With regards to the backends, the next one on the roadmap that we're focusing on is VLLM support, and we also have another backend that's a little bit different. But yeah, we'll be talking a little bit more about that in probably around the 4.5 release of Docker Desktop. But yeah, one of the other things we're looking at is doing like pass-through backends. So like if you want to use the same Docker model runner API endpoints, we could pass those through to OpenAI for you, for example, or for other backends. And so that's something like, again, it's not really confidential because we're developing it in the open. So if you want to kind of get an early scoop of like what's happening, you can also just go to model runner / polls and see sort of what's happening with certain PRs, that kind of thing.
That's awesome. I like both the transparency and that the new stuff is coming. And personally, Max, if you would come and implement an MLX backend for my Mac, I would be very grateful. I haven't looked at it myself. Maybe I can contribute something as well there, but probably beyond my experience level was this area.
Yeah, I mean one of the big pieces that comes into it is that we want to have all, at least for now, generally speaking, want to have all of our backends implement the OpenAI API, just because it's
Yeah.
kind of the most ubiquitous in terms of tooling compatibility. And for some of these, like with Llama CPP, there's a server component. So like I should just shout out to the Llama C++ community. Like we're definitely taking advantage of the like amazing open source solutions that they've given us essentially. Um, and this is also why we're trying to upstream any like patches that we make so we can contribute to that as well. But in the Llama C++ case, we had the server available for the OpenAI endpoints and all the inference backends. So that was kind of a very turnkey solution. And these other backends that we would like to add, it's mostly just a question of kind of fitting them into that same mold. And so they're not all designed exactly the same way. And then they also have additional runtime dependencies like, the Python runtimes and that kind of thing, which inside a container is very easy to ship. Outside, like on your host on your desktop, is a little bit of a different story. And so there's some technical complexity around that. But that's mainly what kind of we're working on right now is exploring those other types of backends. But the Llama C++ case was just so self-contained that it was kind of an easy no-brainer to start with.
Yeah. No, Llama CPP is absolutely amazing. So thank you for them to do this. You mentioned VLLM, which is a production sort of what people usually run in production, I think, right? Do you have production aspirations? And also, how would you go about running Docker model runner in Kubernetes clusters, right? Because if I'm building my applications and I will depend on Docker model runner as the provider for my AI kind of sort of components, I want it to run throughout my DevOps pipeline, right? Like I want to run it locally on my machine. I want to run it in my CI, which it is possible, as we saw. But in production, I'm going to run Kubernetes. Do I still run model runner? And are there any gotchas there? Did we have to overcome any like super hard hurdles to get that working?
Well, yeah, so there's a couple answers to this. Like, yeah, like you said, we really want the model runner experience to look the same all the way from like dev inner loop, like what you're doing on your laptop before you create a PR, out to like the production environment. Like, obviously, they look different, right? You can't make everything completely unified, but we want to make the artifacts that you're working with and the code and the APIs that you're working with the same from like, inner loop out to production. And so we have a couple of different stories around production that we're working on and exploring, and some of them are already launched and some of them are in the pipeline. So obviously Docker CE is one of them. Not everybody uses Docker CE for production, obviously, but if you're a small startup, for example, where you have a relatively simple application, using Docker CE on a GPU-enabled cloud VM might be an option for you. At We Are Developers, we recently announced integration with Google Cloud Run. So
Oh yeah,
actually, yeah. So we haven't talked about it yet, but we could talk about it in a bit. But we have integration with Compose projects. So your standard Docker Compose projects can now reference models and use them for building agentic applications. And so we now have a way where you can actually just take that same Compose project and do, I think the command is like gcloud compose up or gcloud run compose up, I think, and basically put that compose project out into a Google Cloud Run cluster and run it in production that way. So that's another way we could do it. And like you mentioned, the third thing we're kind of looking at is Kubernetes support. And that's something that is still in the development stage, but I could kind of show you actually what it's going to look like. I think it's this one. Yeah. So again, it's still in the development stage. This is just kind of this is an example Kubernetes YAML for running this in the Docker desktop Kubernetes cluster. But we're going to basically provide this same type of YAML for, EKS and other like cloud-based platforms. But obviously the thing with Kubernetes is it's not like a cookie cutter solution. Like there's not a one size fits all. So our goal here is initially at least to provide kind of a recipe book for people who have Kubernetes clusters and they want to make Docker Model Runner available. But the architecture and the actual code that you're going to run are going to be the same, right? So you're going to have some sort of persistent volume where you can store model data. Ideally, you're going to want certain performance characteristics there because these like tensor weight files can be quite large. So you need to be able to load the fast. And sometimes you need stuff like memory map ability to load them efficiently into memory. you have a PVC to kind of link that to your services and pods. And then you can actually use the same Docker/model runner image that we use for Docker CE, and actually we use for Docker offload as well. And you just configure that with, you can set up CORS behaviors so that you can, in this case, it's just set up for a demo, so because I have OpenWebUI as another service in here. But yeah, you basically mount in like the model storage PVC into /models. You set a port that you want it to listen on. You have health checks that you can do. And that's about it. And you can expose that to other services in your cluster or other pods in your cluster. In this case, we just create a Docker model runner host. But yeah, you can, and then so like here's an example of how you would actually access that. So we create this this exposure for the Docker model runner, and then we have OpenWebUI set up to actually talk to that. So its base URL is just this Docker model runner service within the cluster. Again, the OpenWebUI part of it is just for demo purposes. It's not like part of the core setup,
Yeah.
but that's the idea.
So in a nutshell, in a Kubernetes cluster, you need to take care a little bit of the infrastructure, right? Like you need space to store the models. You need to share them efficiently among the pods that run model runner, because you don't want every one of them to get models into themselves. That would be dumb, right? And then you're just wiring the networks around so everything has access to everything.
Yeah, and this, I think one of the things that's really nice about like inference APIs and the OpenAI API in particular is that the APIs are relatively lightweight. So the model runner does not need to be, and like, and you know, inference requests could take several seconds. So you don't need to have like sub-millisecond latency necessarily to talk to the model runner. So you could have like a single model runner instance. You probably wouldn't do this as like a daemon set where you have one on each node, right? It would probably be like a dedicated service that exists on some, you know, node with like a GPU taint or something like that. Again, it's going to look different for everybody. So our goal is to just sort of provide recipes for it. But when you're thinking about it, I think you can look at it from the perspective of like, it's very cheap to send API requests to this, to inference and get responses back. Even if you're sending some binary data, it's still gonna be relatively cheap compared with like a super intensive, like RPC style API. So yeah, I think it's gonna be one of those things where we sort of experiment. Like we're gonna put out kind of a recipe book of Kubernetes YAML, see what people like, and then we'll kind of iterate and see if maybe we can even build some automation into the tooling, right? Like you could have like a Docker model Kate install or something. I mean, it's all hypothetical, but you kind of get the idea.
Yeah. It could become a building block of the future. Right. So, no joke, seriously.
No, I mean, yeah, you know, it's interesting because it's like you kind of have to invent the future, like especially in the AI space right now. Like it's, I hate to use that like kind of really overdone quote about like skating to where the puck is going to be, but like there's not a lot of people who are actually doing, or let's say there's a very few very skilled set of people who are doing like large scale AI deployments in production, right? But that's what we want to enable. We want to enable people to be able to build those applications and have the tools ready for them and the abstractions ready for them and the infrastructure ready for them when the time comes.
Right. So I want to quickly ask you about one last thing. So very often, right, there is a ton of things in AI. Everything is moving at the light speed, and most of what my experience with AI things is gluing things together. So there are like front ends, there are AI assistants, there are applications, there are like language frameworks, there are like myriad of libraries, and they do something, and I don't always know what they do, but I can try to configure them for my purposes. Like recently, for example, I enabled some terminals to work with Docker model runner as a backend, and they, of course, like when they ask me about the configuration, I give them the URLs. And then I kind of hope that it all works, because if it doesn't, like, I don't know what goes wrong, because there are like any number of things that can go wrong. Like it could be the model is maybe broken, or it could be the GGUF template is weird, or it could be that like my configuration is wrong, and it's like super awkward to debug. So like, do you have an advice? How can I go about debugging like complex things like this to at least understand what my Docker model runner backend is doing?
Yeah, you have a couple of different options. So one, if you actually send a request to Docker model runner that for whatever reason kind of explodes, like maybe you specified a context size that was larger than your GPU could support. Generally speaking, we'll send an error response back that will contain some message there. We also have a, I don't know if it's going to work here, but we have a Docker model logs command that will spit out well, actually, it'll spit out a bit more than just the llama C++ logs, but it will spit out those as well. And you can kind of see, like, here's an inference call that happened a little bit earlier. And generally speaking, if there's some sort of error, it's going to be logged in the Docker model log screen. But let's say let's say you're building an agentic application, right? And you have like multiple requests that are going to like different agents, or sorry, to different models, and like everything is like there's no errors, but like things are not working the way you want them to for whatever reason. We actually have a new feature.
That's my case. That's my case. Stuff
Yeah.
never works the way I expected, but
Well, it's very non-deterministic, right? And that's part of the issue. But like, so this is a new feature we're going to be bringing in Docker Desktop 444, which is coming at the end of this month. So let me just pick a model here, like Llama 3.2, and say like, how are you doing today? And it's going to tell me something really mechanical, like I don't have feelings or something. But anyway, but we have this new request tab in Docker Desktop. So let's say you have an agentic application that's talking to Docker Modeler in Docker Desktop, and it's using models X, Y, and Z. So if you go into the models tab and you pick the model you want and you go over to this request tab, you're now going to see this sort of inspector GUI where you can inspect the actual prompts and responses that are going into your models. So if you look at the request tab, you'll see the raw OpenAI request that's going in, or OpenAI API request, like the format of it, and then the response that came back. And these are going to be ordered. You can sort them by whatever you want, but they'll generally be ordered by like most recent. So if you have an interchange between agents, like let's say your GitHub tool invoker agent talks to your like issue list summarizer agent or something like that, right? You can kind of go in and drill through and see the individual like conversation that they're having and make sure that that's not going off the rails. Because sometimes looking at this is not exactly the easiest to parse as a human being. So, having this panel you can drill into is a little bit easier.
You don't even have the prompts here. I need the prompts. I need to see what is actually like what was the system prompt or what was the thing. So I need this. I need like this. I like this UI was the request response inspection. I like very, very much. Cool. That is awesome.
And it's coming soon. It's like within, I think, 2 weeks or so, something like that.
We'll see if this episode will see the light of day on the public YouTube servers.
Yeah, so maybe it's available right now. Go check it out.
Check it out. Leave the comment below. Just kidding. Right. Thank you. No, this is great. This made my day. I just needed something like this earlier. I need to update to my nightly and see if it's there or not. Thank you so much. This was most of the episode. We have some questions, so we're gonna take a little bit more of your time.
Sure.
And then if you have questions and you're currently in the audience and we touched on some topics that you feel really passionate about, but we didn't go deep enough, please ask questions. Even if we don't get to them, it would be very, very nice to see that you care, and also to plan for the next episodes. Right. So we have one question from James. Can you talk a little bit about security around the models on Docker Desktop?
Yes.
Anything in particular, considerations that went into that? Your like kind of sort of threat assessment.
Yes, I mean our view, like, so there's a couple of ways to look at it, right? Like one is like we do have additional sandboxing, and that's something that's on our roadmap for the inference engines that run, because these are running outside the VM. So our assessment was based on the fact that like inference is mostly a numerical operation, kind of the exploit surface around that is just going to be the server going into actually running that process. And so in Docker Desktop, we already have a special host name called host.docker.internal that allows containers to talk to external services. So like if you run, say, a Python application on your host system, you can talk to that from containers. So our thought was Sorry about that. But actually, yeah, there's to your point about security, like there's Docker hardened images at work. Um, yeah, so our thought was that basically like the security profile was the risk profile was pretty similar to that. Um, and the actual like exploiting of an inference process was probably a lower cross section. Now there are threats and like known threats in the wild against that, and so that's why we still want to have eventually sandboxing on the host, and that might take the form of like containerd based model runner, although there's some complexities with that, or it might take the shape of like some custom sandboxing that we do, kind of like what Chrome does with its tabs. So that's something we're still looking at, but our assessment was essentially the risk profile is pretty similar to what already existed in Docker Desktop. But yeah, we did something we thought about. It wasn't a decision we took lightly, but we thought that for the case of performance, it was, and for the case of inference in particular, where like without the GPU for performance, it's like kind of a non-starter. It was worth the trade-off for now. And of course, if you want to, you can always go into settings, beta features, and disable Docker model runner, and then you don't have any of those kind of security concerns. And you can also do this through the admin settings.json, like the org level policies where you disable features. So that's also available to organizations that are maybe a bit more security conscious.
Yeah, don't disable it. Like, it's amazing. It's local. It's great. But if you need to, you can do that. Thank you. There's another question from Sergey about any plans for the multimodal support in DMR, like picture upload or voice to speech.
So we
speech
just
to text or something.
We just added support for, I think it's merged already, but we just added support for like projectors in the OCI artifacts that we ship with models, and there's a few more steps in terms of like actually implementing this and getting it inside Docker Desktop. But yes, it is on the radar, and it's something that's on the radar for the very near future. I don't know the exact date, like, or the exact release that we're going to ship it in yet, but I would say it's going to be soon.
Right, and it's the same thing behind the OpenAI compatible API, right? It's
yeah. I don't know, like, so you can do it through a couple different OpenAI APIs, right? Like they have dedicated audio and image and video APIs, but then I think you can also just do it through like chat completions and I think responses as well.
Right.
But yeah, generating cat memes is very near and dear to our heart, so we're going to try and get multimodal support as soon as possible.
That is awesome. I have a couple of audio models that I would like to run, and both that consume audio and those that produce audio, and it will be very interesting to see.
I mean,
whether I can build some.
More seriously, I mean, there are like a lot of completely genuine applications like OCR, for example, where like being able to do being able to provide an image to a model and have it do something with that, like the image to text translation would be useful.
Absolutely, and like accessibility options for the models that do like recognition of things, your computer usage as the basic example for looking at things, speech recognition for easier integration with like applications. That's there's no, like, it's not a secret that all model providers, cloud model providers, very quickly added the audio video capabilities very early in the current hype cycle. So that's good.
I think for us, one of the limiting factors has been that we're really kind of all in on this OCI compliant artifact format, and so we want to think very carefully about, like, again, adding fine tuning adapter layers or projectors for multimodal support, that kind of thing. We don't want to just like haphazardly like jam stuff in. But again, it's a fast developing space, so we also need to kind of move faster. So it's a bit of a balancing act, but that's one of the things, is like we just want to make sure that this OCI compliant specification is going to be evolvable and be able to support future artifact types and different layer types for these models.
Yeah, that's good to hear. We don't like the cavalier attitude to changing specs on a whim. That is true. So great. Right. Thank you so much. We're at time. Thank you everyone who is watching. We're gonna have more episodes around AI and around Docker products. So stay tuned. Subscribe to our channels, take contact. Don't be strangers. Send us questions, send us emails with feedback. We are always willing to learn. And thank you for being with us. This was an awesome stream. I think we learned several things, and it was very, very interesting for me personally. So I hope for the rest of you as well.
Yeah, thanks for having me.